We are going to talk about scope of inference. Before we can talk about scope of inference, we need to talk about what is an inference. A prediction? Let's make a list of things. What else do you guys think of when you hear inference? An educated guess? Okay. Anything else? I like hopes and dreams. Maybe. I hope this is what's happening. No, that doesn't really fit. Okay. In the statistics world, what do you think an inference would be? Not just a guess. A conclusion based on what? A sample. Okay? An inference is a conclusion based off of a sample. Okay. And how a study is run. I'm going to sneeze. Thank you. Thank you. How a study is run tells us what kind of conclusions we are allowed to make. That's a huge idea. Okay? Now, let's talk about the word significance. Because people misuse the word significant a significant amount of times. Okay. For example, I might say there's a significant difference between my 8th period class and my 7th period class. What does that even mean? An important difference? Does anybody want to guess what significant means in a statistical world? What makes it notable? All right. Unlikely. Guys, remember Lady Adeline? Can she take taste the difference between milk first and tea first? And what convinced you that Lady Adeline could taste tea first versus milk first? Okay. Guys, when I said, are you convinced at getting 3 out of 3 right? You were not convinced. Am I right? 3 out of 3 didn't convince you. 4 out of 4 didn't convince you. And all of those are she got all of them right. Kind of. It's related to replication. Okay? I don't know. There's like a lot of undercurrents in this. Okay? It's kind of like replication, but 4 out of 4 didn't convince you because even though she got 4 out of 4 right, you guys still believe she could do that by just guessing. Random chance could have allowed that to happen. So think back to yesterday when we were was it yesterday we described the different types of experiments? Okay? Think back to somebody asked, well, what happens? I don't know if it was in this class period. What happens if our music time and our no music time is about the same? Is that a possible result for an experiment?
Yes.
You know what that means? Not significant. Everybody good? Okay, significant differences are large enough differences that they are unlikely to occur by chance alone. It's not just that they're big. It's that they are so big that it couldn't have happened by chance. If it didn't happen by chance, what did it happen by? The treatments. Everybody good? So let's say the difference in mean times of your music and not music is like 5 seconds. That's not significant. If it's a minute and a half, 2 minutes, that could be significant. Are we comfortable with this idea now? Okay, so just because we run an experiment does not mean we will get significant results. In fact, a lot of them do not have significant results. And when that happens, you don't get to make any conclusions at all. Everybody good? All right. Now, I said, how we run a study becomes really, really important. Oh, before we get to this. Okay. In an experiment, so this only applies to an experiment. If the differences between the treatment groups are unlikely to occur by chance, then we can conclude they occurred because of the treatments. Which is lovely, because if we can conclude that, we are essentially concluding cause effect. Now, here's the deal. There's 2 things we need to think about when we decide what inferences are we allowed to make, okay? The what are we allowed to conclude, and the who. Okay. If we have an experiment with random assignment of treatments. It has to be random assignment, okay? If we have random assignment, we conclude that gives us cause and effect. If we don't, like we have an observational study, or a very poorly run experiment, then we can conclude a correlation, but we can't conclude cause and effect, a causal relationship. Okay. The who. If I have a random sample, I am allowed to conclude about the population. If my sample is a group of volunteers, I can only conclude about people similar to those in the study. So when we see the word random, that word random can describe 2 things. It could describe how I'm selecting people or participants in a study, or it could describe, hey, I have my people, how am I giving them a treatment? And you have to be discerning people. You have to look at something and say, hey, was this an experiment or an observational study? Does that word random, what is it describing? Is it describing a process or is it describing a selection? Because both are problems, or both are good, but it just it influences what kind of conclusions we can make. So let's go through some examples real quick. All right. Good Lord, I should have done a different context here. I didn't realize I put this here. All right. So, get all the students in AP to participate in a study. Ask them whether or not they studied with music or without. And then look at their GPAs at the end. Did I ask them to listen to music at the end? Or ask them to listen to music or not listen to music? So was there random assignment? How could I assign music and no music if I didn't ask anybody I asked, do you listen to music? Not, you listen to music and you don't. Do you guys see what I'm saying here? Okay, so do I have random assignment of treatments? No. Do I have random selection of participants? No. Is this a good study? No. Not at all. All right, so let's go ahead and say we did see a significant difference between the folks who listened to music and the folks who didn't. What would we be allowed to conclude? For AP Stats students, people like those in the study, there's a relationship between GPA and studying while listening to music. Not a very strong conclusion. Does that mean nothing? Does that mean there's no conclusion? There is a conclusion there. And heck, sometimes I would even use that as if I were you guys and I saw that, I would still consider listening to music while I study if the difference is significant. Now, what if there was not a significant difference? Then it doesn't matter no matter what. Are we feeling okay so far? All right. Study a random sample. So now instead of asking just AP Stats students, I get a random list of students for everybody from the entire building. And I say, hey, do you like to listen to music when you study? And say yes, and look at those kids' GPAs. Do you like to? No? Okay, what's your GPA at the end of the semester? Do you guys see what I'm saying here? Do I have random assignment of treatments? No. Do I have random selection of participants? Yes. Okay, so here's how that changes. Instead of saying for AP Stats students, I'm now allowed to say for all GHHS students. Do we get the basic premise here? All right, now, coming back to AP. I'm going to have half of you listen to music while you study for this semester, half of you not. And I select that randomly, okay? Then we look at your GPA at the end of the semester. Everybody good? Do I have random assignment? Do I have random selection? No. So for here I could say, again, this is assuming that the difference between the two groups was significant, unlikely to occur by chance. Then we might say for AP Stats students, listening to music causes an increase in GPA. Why can't I conclude it about everybody? Because I didn't have a random sample. I only had the AP Stats students, so I can only conclude about AP Stats students. Is this kind of making some sense? Okay, obviously you know the last one is going to be yes and yes. And if we had both a random sample and random assignment, we get to make our strongest conclusion for all GHHS students. Music listening causes an increase in test score or GPA. Now, as I point this out over and over and over again, you guys are going to be, especially in the second semester, you guys are going to get a lot of studies, okay? And is it random by far is going to be the first question you ask yourself. But I don't want you to just ask, is it random? I want you to ask, how did randomness come into play with this? Do you guys see the difference here? Was it selection versus was it assignment versus was it both? Everybody good? All right, we got one more thing to talk about. All right. When you run an experiment, some things require a little bit of thought, okay? So not too long ago, I want you to imagine, and I'm a terrible artist, so you guys will get over this, okay? This is the back of a car. And it used to be, so these are your taillights. Yes, it looks like a pig nose, I got it. Okay? What happens when somebody steps on the brake of their car? The brake lights go on, right? Red brake lights. And so it used to be for those brake lights went off here and here. That's where the brake lights of a car were. Okay? So then they ran an experiment and said, okay, we have some cars that look like this, but then in new bottles, we're going to add a taillight here. And now if you look, cars also have a brake light up in the top of their back window. You with me? And when they did that, they saw this huge decrease in accidents. But then 5 years later, not so much. Accidents went back to where they were per capita. Why? People got used to it. Right? Once you guys, at this point, if you saw a car without brake lights in that top window, it might actually freak you out. Maybe. For those of you that drive at least, I would think. It would flip me out. And I used to, this is way back in the day when Miss Meister was a young pup. When they started adding these things. Don't worry, we didn't have airbags in our cars either. It was a big deal if your car had an airbag. It's like, ooh, I can get into an accident. That like legitimately, that's how it was. Okay, so here's what happens. Okay, so as we look to an experiment, realism needs to be considered. So, man, does that make things hard? Imagine I wanted to run an experiment to talk about texting and driving. Can we all agree that texting and driving is a bad idea? Okay. As someone who rides their bicycle to work, I didn't today. I don't do it on musical days because I don't like riding home during rush hour. Mostly, I don't like crossing Olentangy at rush hour. That's a pretty unsettling feeling. Okay, so half the time I look over, especially stopped at a stoplight, and I see people like this. My favorite is when I see people like this, the light changes, and they're like this, kind of going through the intersection. That's always my favorite. I just have to finish this text that I started while the light was red. You guys know what I'm talking about? It's obnoxious, okay? All right. So can I say, hey, I want to see if it affects Grandview kids. So what I'm going to do is have half of you randomly get in your car and just drive to, I don't know. Where would you guys drive to?
Chick-fil-A.
Chick-fil-A, cool. Can I have half of you drive to Chick-fil-A? Half of you, everybody drives to Chick-fil-A, but half of you go to text while you're driving there. Can I do that? Can I do that and keep my job? Can I do, okay. Why do you guys think I might lose my job?
There's like some problems. People are at more risk.
I am not allowed to do any experiment that I believe would put the people at risk. Do you guys see what I'm saying here? So how do they text this like distracted driving? Well, maybe what they do is they have a driving simulator. Does that make sense? Now, is that real? No. If you know you're in a simulator, are you going to take it as seriously as if you're in a car? No. Sometimes that's the best we got. Are we comfortable with this idea? All right. One more thing. Does smoking cause cancer?
Yes.
Do you know there has not been a single study, an experiment where we assign smoking to some people and smoking to not smoking to other people? Because it's not okay. If I believe something causes cancer, I'm not going to do it. But we've all been told that smoking causes cancer, and you guys, statistically, it still does. Even though we didn't have an experiment with randomly assigned treatments. Okay? So, how many studies do you think have been done on smoking? A lot. When you have a whole lot of studies that all come to the same conclusion, and it turns out that there is a difference in the risk for cancer if you have 1 cigarette a day, a pack a week, a pack a day. The more you smoke, the higher the risk of cancer. And these are long studies that have lasted for a really long time. And so when you have a bunch of stuff, there's still ways to get to cause and effect, but it has to be a pretty substantial case. Everybody good? With lots and lots of data points run by lots and lots of people, lots of studies. Not just Miss Meister has consistently taken this, right? Like paid attention for the past 20 years of teaching. No. It's longer than that. It's like 50, 60 years. Lots of different organizations doing the studies. Isolated. So, everybody good? Now, last thing I'm going to talk about. Have you guys ever heard of an IRB? Stands for an internal review board. Okay. Anybody who ever runs a actual study, like in the real world study, not Miss Meister wants to know if listening to music makes a difference, right? Okay. You cannot run an experiment on people without it going through some sort of independent review board. I said it internal. It's an independent review board. So when people at universities or people are doing experiments on people, they take everything they want to do and they take it to people who aren't related to their study and say, hey, does this look okay? So you never let the person who wants to do something decide if it's ethical. Do you guys get what I'm saying here? Even the most ethical people, not ethical. I don't want to say are not ethical, but are subject to being tempted to try something that maybe doesn't pass muster, if you know what I'm saying. Okay.